Welcome back, guys. So this is question 2.27 of our book Electric Circuits by Nilsson, and the statement of this question is the current I1 and I2 in this circuit in figure P 2.27. So this is the figure, okay, are 21 amps and 14 amps. Okay, so this is I1, this is I2, and the values of these are given as well. So the value of I1 is, that is 21 amps, and the value of I2 is that is 14 amps. So this is the given data. On the basis of it, part A of it is find the power supplied by each voltage source. This is the 147 volts voltage source. This is again another 147 volts voltage source, and we have to find the power supplied by them. And B is show that the total power supplied equals the total power dissipated in the resistors. So in all of these resistors, we have to find out the power which is absorbed, okay, or dissipated. Okay, so these two are the power supplying sources, while these other are the resistors, which are the passive elements. In order to find the power supplied by the voltage source, what can we do here is that the formula for it is, let me write here the formula. So the formula for it is P equal to I into V. Okay, so the voltage is known, so therefore V is known, while we want to find out the current. So from it, the current here is, let me call it I naught, and from it the current, let me call it Ix. Okay, we want to find them here. So after finding them here, what we will do, the power supplied by the first 147 volts voltage source is, that would be the value of voltage source, which is 147 multiplied by the current, which is here I naught, and for the other one, that is 147 as well, this is for this one, it would be 147 multiplied by the value of the current, which is Ix here, this one. Okay, so now let me solve it, and in solving it, let me use another color. So this is also, in order to draw the voltage or the circuit here, what we have is, this is it, and this is the resistor. Okay, this is 35 ohm, this is 5 ohm, this is 10, this is the resistor, the voltage source. Okay, so it is connected here, this one is another. Okay, so these are all connected here. Let me take this one as the ground one. This is plus minus 147. Again, this is the plus minus 147. Okay, this is, sorry, this is another resistor. This is 2 ohm. Okay, 2, this is 1, this is 1. Okay, and these are here. Okay, let me call this voltage as V naught. Okay, the currents which are given here are this one and this one, and we can see here that if the voltage across this 5 ohm resistor is V5 and this is V10, okay, and the current through this 35 ohm resistor is, that is I35. Okay, and the current here, let me have this current, this is I of X, this is I naught. Okay, from it, let me write some equations. From it, let me write some equations. So we can see that this branch and this branch, these two are in parallel. So therefore, we can see that V naught is equal to what? That is also V35, which is across this 35 ohm resistor, and also this is the voltage drop across this 5 ohm and this 10 ohm. So therefore, it is V5 plus V10. In these resistors, we can very easily see that the value of the resistance is known, the value of current is known, so the value of the voltage can be easily found out by using the Ohm's law. So therefore, V is equal to IR. So I is here what? That is I1. So I1 multiplied by 5 ohm plus the value of V10 is I2 multiplied by 10. Let me write their value. So the value of I1 is 21 multiplied by 5 plus I2 is 14 multiplied by 10. Okay, so this would be what? This would be 105 plus 140. So the value of it is 245 volts, which is V0, which is V35, and this is the value that is known. Okay, so if the value of the voltage across 35 ohm is known, we can very easily find out the value of current. So the value of I35 is what? That is V35 divided by the 35 ohm. So 245 divided by 35. Okay, let me find the value of it. Okay, so it is 245 divided by 35, that is 7. Okay, so this is the 7 amperes. The value of I35 is now known. Now here we can see that in order to find the value of I0, we can see that this is the node, the I0 is coming towards this one and then splitting into this current and this current. So therefore applying KCL here at node V0, we can see that I0 is equal to I1 plus I35. Okay, putting values here, the value of I1 is what? That is 21 plus the value of I35 is 7. So the value of I0 is 28 amperes. Okay, this value is known. Now in order to find out the value of Ix, what do we have to do? Let us first find this voltage and let me call it V0 prime. Okay, so in order to find the value of V0 prime, here in this branch we can see that the potential difference divided by the resistance is equal to what? This voltage, this current, okay, or this V0 minus V0 prime is equal to V5. Okay, this is the potential difference formula. So the voltage applied minus the voltage remaining is equal to the voltage consumed. Okay, so this V5, this is already known. In order to find out the value of V0 prime, it will be V0 minus V5 is equal to V0 prime. So now putting values here, the value of V0 is already known, that is 245. Okay, the value of V5 is, the value of V5, that is here and here, this is 105. So finding it out, the value of V0 prime is 245 minus 105 is 140 volts. Okay, so this is 140 volts. This voltage is now known. Now in order to find out this Ix, we can see that this current is coming towards this junction, this current is also coming towards it, and this Ix is also coming towards it. So let me add them all together, and here it would be, according to KCL, it will be Ix plus this current, which is I2, plus this current, that is I35. This must be equal to 0. Okay, so now in order to find the value of I of x, it is minus I2 plus I35. The value of I2 is 14. The value of I35 is how much? That is 7. Okay, so it was minus 21 amperes. Okay, so the value of Ix is also known. So the two values, I0, this is I0, this is 28 amperes, this is known. So 147 multiplied by 28, and in this is 147 multiplied by the magnitude of it, because this is the voltage supplying element. So the magnitude of it is 21. Okay, so when we will calculate it, we will get the desired values. So let me find them out. Okay, so here it is 147 multiplied by 28, that is 4116 watts. Okay, and for it it would be 147 multiplied by 21, it would be 3087 watts. Okay, so these are the answers of part A of our question. In order to find the solution of part B, we need to find out the currents in each of the resistors here, and then we will apply what? We will apply the formula, which is P is equal to I square into R. Okay, so the values of the resistances are known. This is known, this is known, this, all of these are known. What do we have to find out? We have to find out the currents here. Okay, so this current is already known, which is here I35. This current is known, this is known, this IX is also known, which is flowing towards it. This I0, which is flowing towards this, is known. What do we want to find out? This I2, let me call it I22, and in order to find it out, we should have this voltage. Okay, so let me call it Vx. Okay, so this is known. So now here applying KVL in this branch, okay, applying KVL here in this branch, what we will get? We will get the value of this Vx. Okay, so after we find the value of Vx, we will apply here what? This voltage is already known, that is V0 prime. Okay, so we will find it out and the current will be known. So let me solve it here as well. Okay, so let me use the KVL here. So applying KVL here, writing the equation, and we can see that the direction of the current which we had taken earlier on, this was I0, and it was from this point to this. So the actual polarity was this plus minus. Okay, so therefore applying the KVL here, we will have here this V0 from this to this point. This will be V0, and then this is the negative positive. So therefore the polarities of this V0 and this is same. So therefore it will be V1, and this one plus minus. So it is opposite than that of this. So minus 147, and then this is also opposite, and this is minus Vx. This must be equal to 0. Okay, so the value of V0 is known, that is 245. Okay, the value of V1, which is the V equal to IR, the value of I0 is known, the value of I0 is 28, and the value of R is 1. So IR is 28 multiplied by 1 minus 147, that must be equal to Vx. Okay, I have bring it here. Okay, so finding them out, what we will get, Vx is equal to, let me solve it by using the calculator. Okay, so 245 minus 147, that is 98, plus 28. So this is 126. So the value of Vx is 126 volts. Okay, so this voltage is known. Now in order to find out the current here, it will be Vx minus V0 prime, which is the voltage here, potential difference, divided by the resistance, which is 2. That is the current which is flowing through this, and that is, let me call it I22. So let me find out the value of I22. Vx is 126 minus value of V0 prime, that is, where is it? That is here. So that is 140 divided by 2. So it will be what? It will be 14 divided by 2. So that is minus 7 amperes. Okay, so all the currents are now known, and now what do we have to do? We have to put them all here, and then we will add this and this together and see that after finding the voltage drops across each resistors, then adding them, the sum will be equal to the sum of these two quantities. Okay, so that is basically the solution of part B of my question. So that's it for today. If you guys have any question, regarding the solution of question 2.27, you can ask me in the comment box. See you soon.